Hi, today we're going to do lesson 6.2. It's use proportions to solve geometric problems. So our goal here is we're going to solve proportions to solve use proportions to solve geometry problems. So last lesson we worked with proportions. We're doing the same thing here. So some additional properties of proportions that we need to make sure we understand is the reciprocal property. If two ratios are equal, then their reciprocals are also equal. And we've talked about the word reciprocal before. It just means you flip the top and bottom. So if A over B equals C over D, then B over A equals D over C. We just flip the top and bottom there. The next one, if you interchange, so switch around the means of a proportion, then you form another true proportion. So if you switch these two means around, so if I have A over B equals C over D, then A over C equals B over D. That's another true proportion. The next thing, in a proportion, if you add the value of each ratio's denominator to its numerator, then you form another true proportion. So if A over B equals C over D, then A plus B over B equals C plus D over D. So these are more true proportions. We're going to use this because when we're doing problems, there's more than one proportion that you could write to find the same exact answer. So say maybe you're working with your neighbor, your friend, and you're doing problems. You might both set up different proportions that still get you the correct answer, and you both would still be correct. Okay, so let's look at this first example. We're just going to do some problems, set up some proportions to show all of them that are still true. So in the diagram here, AC over DF, so I've got AC over DF, 12 over 18, equals BC over EF. So it equals BC, 9 over EF, which is X. Right? So I'm just going to plug those numbers in. So 12 over 18 equals 9 over X. That's a proportion that you could write and solve to find X. So since we also know that DF over AC equals EF over BC, all we did was flip the top and bottom here. Okay, that's the reciprocal property. Because that's true, we could also write the proportion. We've got a little too much on here. We could also write the proportion 18 over 12 equals X over 9. I want you to notice here, when I multiply, 18 times 9 equals 12 times X. Good if I multiply here. 12 times X equals 18 over 9. Isn't that exactly the same thing? You can switch the two sides of an equal sign. That's perfectly fine. Another way we can think of it is A over BC equals DF over EF. All you did there was interchange your means of the proportion. So let's set this one up. So I have 12 over 9 equals 18 over X. And let's just check it again to see that we get the same thing. So I've got 9 times 18 equals, oh, I still have 12 times X. So that's the same thing right there. We could also say BC over AC equals EF over DF. So we then took and we just applied the reciprocal property again to the problem from number 3. So we could also write 9 over 12 equals X over 18. And if we write that out, 12 times X equals, we've still got 9 times 18. So notice there are 4 different proportions that are all true that you could write to solve for X in this problem. So looking here, use proportions with geometric figures. It says in the diagram, BD over DA equals BE over EC. Now remember, when we've got 2 capital letters with nothing above them, it means the distance from BD to D over the distance from D to A. So BD is right here, okay, and DA is right here. Well, DA, that's an easy one. That's 3, okay. BD, well, it's a little more tricky because the whole thing is X, but I've got to take away that 3 from the bottom. So BD is really X minus 3. So I've got X minus 3 over 3 equals BE, the distance from B to E, well, that's right here. That's 18 over EC, that's right here, and that's 6. So I've got a proportion set up. I can use my cross products property here. 3 times 18 equals, use my cross products property here, don't forget those parentheses, 6 times the quantity, x minus 3. So 3 times 18, well, actually, I'm going to simplify this a little bit different here. Looking at this problem, let's distribute here. 6 times 3 is 6x minus 6 times, I said 6 times 3, 6 times x is 6x minus 6 times 3 is 18 equals 3 times 18. 3 times 18 is 54. Let's combine our like terms. So I've got 18 over here. It'll become plus 18 on the other side since it's minus 18 there. So I have 6x equals 54 plus 18, which is 72. Divide both sides by 6. You get x equals 12. Okay? So we found that x equals 12. There are other ways that you could solve that problem. Let's now go back and answer the question. The question says find the distance from B to A and the distance from B to D. So B to A, this distance, BA, well, that's just x. So x we know is 12. So my distance is 12. I'm just going to put a U for units because I don't know what it is. Okay. I also want to find BD. So BD, that's my distance from B to D. Well, we know that's x minus 3, so it's 12 minus 3, which is 9. And again, I'll put a U for units. So we answered the question after we found our x. We always have to remember to go back and answer the question that's asked. So on your own, in the example above, BD over DE equals BA over AD. Find AC. Okay, so pause the video, set this up based on the information given, and solve it. Okay, welcome back. Setting this up, you should have set up the problem x minus 3 over 12 equals x over y. But we know that x is 12. So 12 minus 3 is 9 over 12 equals x is 12 over y. Okay, so we can do that because we know that x is 12. And then we just use our cross products property. 12 times 12 equals 9y. So 144 equals 9y. Divide them both by 9. And y equals 16. Okay? So then finding AC here, well, AC was just y, so we did. Y is 16. So AC equals 16. Our next one, it says similar triangles and radiation therapy. Here's our question mark, so this is the one that we want to find, and I better change my ink color since I've got the same color that's on the screen here. So I'm not given much direction here, but I know that I can set up a proportion. Okay? So I'm going to set up a proportion here, and I've got two triangles. Here's one triangle. The bottom of this triangle is 15. This side of this triangle is 100. Okay? I've got another triangle here. Let me grab another color. I've got a larger triangle here. Okay, and it probably goes up a little further than this. We don't know this side length, but this whole side length, that's 100 plus 5. Because I've got this 5 centimeters and this 100. So that whole side length is 105 centimeters. So let's set up a proportion. Remember, I'm going to set one up. You could set up a different one. We've got lots of proportions that are the same. So I'm going to set up my bottom here is what I don't know, so I'll call it x, over the side here, that's 105. And if I did the bottom over the side, the bottom to the side, I have to do the same with the other triangle. So my other triangle, here's the bottom, 15. 15 over the side of this other triangle is 100. So I made sure the bottom of both triangles was on the top, and the side of both triangles was on the bottom. You could flip these up and down. You could find other problems to write as well. So using my cross products property here, we do 105 times 15 equals 100x. Okay. Multiplying those out, these are kind of big numbers, so I'm just going to divide by 100 first before I simplify this. So x equals, if you do 105 times 15, then divide that by 100, you get 15.75, and that's in centimeters. And that's what we wanted to do. We just wanted to find the question mark here. We wanted to find what that bottom length was, so we did that. Let's look at our next problem. It says the scale of the map at the right is 1 inch to 26 miles. So this is a common problem. You obviously know maps can be drawn as big as they really are. This is very common. It says find the actual distance from Pocahontas to Algona. Okay, so we see Pocahontas and Algona. And they're there, so I have a little marking drawn on my page. If I bring that over here to my ruler, okay, and measure it, I get about 1 1/4 centimeters, okay, or inches actually, we're in inches. So I'm going to have this be 1.25 inches, because that's 1 1/4 inches. So I've got 1 inch to 26 miles, that was given to me, and I have 1.25 inches, and I want to know how many miles is that? That's what I'm trying to find. Well, looking at this, don't my units just cancel out? I've got inches and inches, and miles and miles. Okay, so my units are the same. I'm okay there. Let's use the cross products property here. 26 times 1.25 equals 1 times x. Well, 1 times x is just x. So 26 times 1.25 is 32 5/10. And our units there is miles. Okay, so 32 5/10 miles. Let's look at our next one. It says you buy a 3D scale model of the Reunion Tower in Dallas, Texas. The actual building is 560 feet tall. So I know the height of this building, that's really 560 feet. Okay? And the diameter of the dome on your scale model is about 2 inches. Okay? So I'm going to draw a little scale model here. Okay? So I've got this Reunion Tower. Okay, here's my model. And I know it says the diameter of my dome, so across my dome here is 2.1 inches. Okay? And it says my model is, oh, I read that wrong. My model is 10 inches tall. Somehow missed this. I'm looking at it thinking I have one piece of information from both pictures. That's not enough. But it says your model is 10 inches tall. So I know this height right here of my model is 10 inches. Questions, what's the diameter of the dome in the actual building? So we're looking for this diameter right here. So hey, let's do what we've been doing all along. Let's set up a proportion. So I'm going to use the height of my model over the diameter of my model. And I could have flipped that around and done diameter over height. But I did the height of my model first and put that on the top of my fraction. So I've got to put the height of the actual tower on the top of my fraction here. So I got 560 feet over, and I don't know the diameter of my actual model, but I know I'm going to have it in feet. So over x feet. Okay? So let's solve this. We've got inches over inches, so those aren't going to cancel out. And we got feet over feet, so those will cancel out as well. We're going to use our cross products property here. So 2.1 times 560 equals 10 times x. If I divide both sides by 10 here, put that in your calculator. 2.1 times 560 divided by 10, you'll get 117.6 feet. Okay? And the question is, what's the actual diameter of the dome? And we found that. If you want to check your answer, what you could do is put 117.6 back into this. And if you do 10 divided by 2.1 and 560 divided by 117 and 6/10, those two should be equivalent to each other. So this is our end of the notes for lesson 6-2. Remember, if you had any questions at all, make sure you start them so that we can go over those questions in class tomorrow, and have a good night.